Hi everyone, I am Kimberly at Deyta and today we will discussing about the dividing edge. But before that, let's see our learning objective for today's lecture. At the end of this lesson, students be able to identify the main types of dividing heads, explain the basic function of the dividing heads, and key parts of the dividing heads and their purpose. So first, what is dividing heads? A dividing head is also known as an indexing head. It is a specialist machine tools attachment designed to precisely rotate a workpiece in predetermined increments. The indexing or dividing head is one of the most important attachments for the milling machine. It is used to divide the circumference of the workpiece into equally spaced division when milling such items as gears, splines, squares, hexagon, and octagon. It is also used to rotate the workpiece at a predetermined ratio to the table rate to produce cams and helical grooves on gears, wheels, reamers, and etc. Types of dividing head. Dividing head can be split into three types. These are closely related to their size and complexity. These are the plane, the semi-universal, the universal. On the plane dividing head, there is a simple fixed horizontal spindle that is rotated using a worm mechanism. It is a simple fixed in horizontal spindle that is rotated using a worm mechanism. In this case, the dividing plate is always permanently fixed in position. The semi-universal dividing head. It is similar to the plane dividing head, but the spindle can be tilted. The semi-universal dividing head, it is similar to the plane dividing head, but the spindle can't be tilted. On the semi-universal dividing head, the spindle will tilt so its axis will move from above 5 degrees below the horizontal to about 5 degrees past the vertical. In this case, the dividing plate is always permanently fixed. In other words, it does not rotate. The universal dividing head. It has an auxiliary input at the back of the head. The dividing plate can either be fixed or it can be rotated by turning the auxiliary drive shaft. In this case, firstly, the shaft can be tilted. Secondly, and what makes the universal dividing head universal is that it has an auxiliary input at the back of it. It's when this turn it rotates the dividing plate. In the case of the universal dividing head, the dividing plate can either be fixed or it can be rotated by turning the auxiliary drive shaft. When used as a plain dividing head, the dividing plate is locked in position. When used for the helical milling, the dividing plate is unlocked and can be turned by means of the auxiliary input. Next is the universal dividing head set. Consists of the headstock with index plate, headstock change gear and quadrant, universal chuck, footstock, and the center rest. This feature is a universal dividing headset where the headstock is located on the right side of the picture while the footstock is on the left side, and the center rest is between the headstock and the footstock.
Hello everyone, I am Kassandra Dischoso and I'm going to discuss the part of indexing or driving head. The first is swelling block. Mounted in the base enable headstock to be tilted from 5 degrees below the horizontal position to 10 degrees beyond the vertical position. The sides of the base and the block are graduated to indicate the angle of the settings. The second is spindle. Mounted in the swelling block is a spindle with a 40-tooth worm wheel attached which meshes with a worm. The third is worm. At the right angle to the spindle is connected to the index chunk, the pin of which engages in the index plate. The last is direct indexing plate. A direct indexing plate is attached to the front of the spindle. So let us proceed to the image. The image shows a cutaway diagram of a dividing head, a device used in machining to accurately divide a workpiece into equal parts. The first is index plate. The circular plate with holes used for indexing. Index pin. The pin that engage with the holes on the index plate. Index jack. The handle used to rotate the index plate. The sector arm. The arm that connects the index junk to the index plate. Index head spindle. The main spindle that holds the workpiece. Worm wheel 40 teeth. The gear that meshes with the worm shaft. Worm shaft. The shaft with a single thread that drives the worm wheel. This image is a cutaway diagram showing section through a driving head focusing on the spindle and index plate mechanism. Spindle. The central rotating shaft that holds the workpiece. Index plate. The plate with regularly placed holes used for indexing the workpiece. Index pin. The pin that engages with the holes in the index plate. Index crank. The handle used to rotate the index plate. Worm wheel. The gear that meshes with the table worm. Table worm. The worm gear that drives the worm wheel. Eccentric or disengaging worm. A mechanism to disengage the worm drive. Trunnion. The support structure for the driving head. Clamping strap and swivel block. Mechanism for securing and adjusting the workpiece. The image shows two methods for attaching a workpiece to the spindle of a driving head using a 60 degrees center. A 60 degrees center is inserted into the front of the spindle. This method is suitable for workpiece with a pre-drilled center hole. Using a universal chunk. A universal chuck is threaded into the end of the spindle. This offers a greater versatility as it can hold workpiece of various shape and size without requiring a center hole. Footstock. It is used in conjunction with the headstock to support workhead between centers of the end of workhead in the chuck. May be adjusted longitudinally to accommodate various length of work and may be rise or load off center. It may also be tilted out of parallel with the base when cuts are being made on tapered work. Center rest. Long slender workhead between centers is prevented from being by the adjustable center rest.